So, handles are a pretty important part of a lot of products, so let's go through some of the options that are available for whatever it might be that you're designing. So we recently did a video about the design of handles for individual products, and it got a pretty good response, so we thought we would do a part 2 here. So in this video, we're going to go through a number of different handle options that are available and how to design so that they can be optimized for 3D printing and might be a better solution for your individual application, whether it might be a mug or an enclosure or a box or whatever it happens to be that happens to have a handle. So let's get started. The first handle that we're going to look at is basically no handle at all. If you don't need a feature, do not use it. A lot of products just need an area to kind of catch a finger so that you can pick up something heavy and get a little bit of grip on it. These nubs are a very easy way of doing that. And there's actually the option to invert them so that they are divots and dimples inside the side of the part so that you can have a better grip on it as you are picking it up or grabbing it so that the fingers can catch underneath. This is often done by just a general hemisphere and is a very simple type of handle to use, though it's technically really no handle at all. But if no handle at all is a place to start, if you can get away with it, then let's go to the opposite end and have a handle everywhere. You can actually design handles that wrap around the entire outer circumference of a part. These type of handles allow people to get access to whatever your piece may be from any direction, and they can be very reliable and very strong. They're also very easy to design, especially if you have a circular option like this. But these handles do suffer from the fact that you don't really get a lot of grab on them, but they can work very well for trays or individual containers where you just need to get a lip on them pretty easily and you would like to have a full 360 bit of access to that part. But then let's go ahead and go into regular handles. The most fundamental type of handle that you can have is actually a rod or a stick coming out the side. But within 3D printing, you have no restriction on the overall design of the handle. It can be thick, it can be wide. There are no restrictions based on the shrinkage of the material. So you can actually take what would normally be a standard dowel or rod sticking out the side and instead expand it and make it wider or thinner, and then even add individual buttons on the bottom so that now you can get a good grip on whatever your object may be, and you can change the handle to the exact width, size, and depth that you actually need so that it is useful to you. So that is a very simple expansion of a very old style of handle, but you have so much more flexibility because again, you can make this exceptionally thick to increase its strength. You can make it wider in this direction so that it kind of wraps around or stretches around the whole object, or it could stretch along the entire edge of a rectangle so that you can have a handle that has good grip and is very simple and easy to use. But then there are the traditional fin handles, and fin handles are a really good option to use, especially in 3D printing, because each individual layer is continuous. When designing handles for mass production, you want to eliminate as many steps between layers as you can. You don't want to have to move right here, retract, and then move over here. So fin handles like this are a very good option, but you can actually add bulbs to the end of those fins to give a better grip so that you can get ready access to whatever it was. And again, you can make that grip larger and smaller in order to match the container that you're actually using. This is a very small thing. This could be like a measuring cup of some sort, or you could scale it up to the size of the mug or to the size of a bucket where you would have a couple of these on either side. And they can provide really good grip and really good traction onto the handle while still being very easily mass producible. These types of handles are not traditionally used with other types of manufacturing because they use a lot of material. If this was molded, then that bulb would shrink and cause deviation and warpage that is not really desirable and creates an inferior product. But you don't have that restriction when using mass production printing. Now, that bulb handle and those fin handles are a really good option because it's a continuous single outline for each layer of the part. And you can take that option and expand it to something like this. We call these eye handles. They're a very simple way to get access to both sides of it. They're generally printed vertically like this. This is the optimum way to do it, where the build plate is right here and growing upwards, but they can be turned sideways in order to create kind of a handle like this, but it's not the greatest. It's best if they're done like this. This gives you easy access to both sides and a very nice, simple member that can be grabbed very easily from either direction. And since it's symmetrical, you have no restrictions on what sides can be grabbed from it. These are a very simple handle and are really easy to scatter around the outer side because you can increase their multiples so that you have key grabbing points throughout the outside of the part. And since they are really distinct from the core of the part, they immediately call out where should be grabbed. And that's an easy way to do it. But this handle is a little bit unhandy because you would have to make those circles very large if you wanted to get a really deep grip on it. So they can be expanded so that you have more range on it. And right here, you can actually grab around like this and get a really good grip on it. And if you want to make them handy for right and left-handed, you can flip them around to the other side so that you can grab right there, or grab both to get a really good grip on whatever your object may be. Though this brings up a good point between right-handed and left-handedness. If you're mass producing a large quantity of parts, you wouldn't want to optimize towards this particular set of the population. But if you are producing mass-produced parts on demand, where a customer makes an order and then that order is produced and shipped to the customer using a platform like Angled.io or our printing APIs or softwares, well then in that case, you could actually provide a left-handed and a right-handed version of this so that a customer can order specifically what they want so that they can make sure that nobody else is stealing their coffee when they want to actually use it. So those are the most basic handles. But since we are working with 3D printing, we're able to create very complex shapes that were never possible before, because with pottery, you don't make really thick objects, because as you bake it, if there's an air pocket, it will expand and cause the pottery to break. And the same applies for molding or traditional types of forming, where really thick materials would cause deformations of some type, because molding materials would cause shrinkage. That's why you can't have these type of bulb features. But again, that's not relevant for printing. You can create any type of feature that you want within reason, so long as it's still manufacturable. This is one of the simplest versions of these. So this is a very simple example of just a hook handle. Now we've shown this S handle before in a previous video, but this is a way of expanding it so that it is more ergonomic. So basically it is a mirror of the fingers themselves so that they can fit right into it while still giving distance from the object and still being comfortable. But this has a problem of not really grabbing onto my fingers really well. I can't really grip it. It's more of a fingertip type of a handle. Still useful because you can get a hold of something like this, which might be useful if you have a high strength need, maybe like carrying shopping bags or some kind of widget or tool where you want to get a grip on it like this. But if you want to hold it like this, a better way to do it would be to add that very thick feature so that a person can really get a hold of it really well with the full wrap of the fingers and not just the fingertips, which is the issue right here. So that extra thickness, which is not possible with really any other sort of technology, is very possible and is very mass producible with 3D printing, because again, it's a continuous outline, but it's very strong and rugged and creates a nice ergonomic grab right there. And then you can change this curve and this overall layout so that it works for your particular application. But again, those are the basic ones. If you want to go full advanced, you can do a full parametric handle, which is the two variations in sizes right here. Again, this one is optimized to right and left-handed. You can expand it so that it can use both, or again, mirror it across much like this one in order to create an ambidextrous type of object. But ultimately, a handle can be grabbed from both sides, and handles very often are restricted to one side or the other. A handle on the right side can only really be grabbed with the right hand, and so on and so forth. So decide what is useful for your product. But these parametric handles are able to change shapes, so they start narrow and then go wider and then go narrow again. And this is a really nice handle because it is perfectly modified to the grip of your hand, to where the thumb lays right there and then the rest of the hand has a thick object to hold on to, as if you were grabbing almost the joystick or the side of a game controller. And you could actually modify this so that it does emulate the design of a game controller. So we'll just call it a controller handle. But these type of handles can be really useful, again, for high ergonomic tasks. You might use it for a handle in a shift, or again, something that people really have to pull and hold and carry for a long time, or even for some type of commonly used object that a person might find in their home and would interact with on a regular basis. This is a really good type of handle because it both looks really good, it looks refined and intentional, but at the same time, it's exceptionally strong. It is within layer all the time, but it's a great looking type of handle while still being very functional. And since it has this angle and gradient on it, it can be flipped around and turned around and used from many different angles and still be very reliable. So there are just a few new handles for you. Hopefully you can use them inside of your projects for whatever you might actually need a handle for. And let us know if there's other types of applications or individual types of hardware that you'd like us to take a look at. These design explorations and ways of viewing different ways of making different products are really fun videos to do, and it's a lot of fun to show what the options are out there to create really good products that can be optimized for mass production with printing. We obviously run a mass production print farm, so we're always interested in educating folks about what is possible and what the alternatives are, because you never want to pull in legacy design practices from other processes, other technologies, and other materials. You want to use the technology that you're using for mass production and designing towards that so that you get the optimum result while still being able to meet all the other needs that the project might have. So you always need to understand what your end process is for mass production, and then design towards that as you are designing your product in order to make sure that you're taking full advantage of that process. Have a great day, everybody.